Now we're going to look at molecular compounds. Remember, there are two main types, ionic and molecular, and they have different naming systems. So ionic is a metal and a nonmetal. Molecular compounds are made from nonmetals only. So it's very important to note that there are no ions in these. So don't be looking up charges and stuff for these. They do not have ions, no charges. Here's an example, xenon trifluoride. It is not in a crystal. It is in little molecules. So this is what we mean by molecules. Each one has these elements as shown by the formula. Naming these is really easy. You just look at the formula and then you use these prefixes to say how many. For example, PCl3 is phosphorus trichloride. Notice that I don't use mono. The exception we make is for carbon monoxide because it was such a well-known compound before they changed the system. So the formula tells you what's in one molecule. It's not necessarily the lowest whole number ratio like we did for ionic compounds. This would be dihydrogen oxide. I'm going to go through all of the examples. It would be a good idea to write them down and see if you can come up with the answers before you look at mine, because you'll learn some if by trying it before you hear the explanation. It's really easy to just listen along and it makes sense, but you need to try it yourself in order to know if you're really learning it. So the first thing you should do is decide if it's ionic or covalent. I told you this is mixed types. If it's ionic, it's a metal and a nonmetal, and you don't have those prefixes. If it's covalent, you have nonmetals only, and you use those prefixes like the di, tri, and so forth. So potassium is on the left on the periodic table. It's a metal. So metal, nonmetal. This one is ionic. And so I just name it. I do end the last one in "ide", but no prefix because it's ionic. Also, the ending is "ide". The ending is "ide" for all of them unless you have a polyatomic ion and then you use the polyatomic ion ending. Let's go down here. So again, this is ionic. I see a metal and I need to recognize that this is a polyatomic ion. That polyatomic ion is nitrite. So this is how did I know that was a polyatomic ion? Well, there are a lot of symbols there. That's one way. But also I should be familiar with the polyatomic ions enough that when I kind of see one, I'm like, oh yeah, that is something. And if you don't remember nitrate, you can look on your chart for now. Okay, next one, phosphorus is a nonmetal. Hydrogen is a nonmetal. So this one is covalent. And remember that covalent and molecular mean the same thing. And so I'm going to use those prefixes, name them in order, but use the prefix to say, we don't say mono, but we'll need it for trihydride. Next one, oh, this one's a tricky one a little bit. So it has lead, and that's a metal, and it has a nonmetal. So this is ionic. What makes this tricky is you have to figure out the charge on the lead. And let me show you how you know that. Lead and tin are two really common metals that are down here. And notice they're not in a column that predicts their charge. In fact, below this zigzag, a lot of these are harder to predict. Aluminum is +3, but so they can have more than one charge. Additionally, on your symbols to memorize on the upper right, it tells you these common metal ions, and it is a really good idea to have these in your head. We see that lead can be either +2 or +4. So we need to decide which lead this is. Okay, the way we decide what charge of lead this is by looking at the charge of the other things. This iodide is in the -1 column on the periodic table. So I know this is neutral, so that means that this lead must be +4. And so I will say lead, and then I'll use my Roman number for 4. Iodide. Again, we end in "ide" if it's an element there. Metal, potassium on the far left, non-metal, so this is ionic. And just name them in order. End in "ide," just an element. Name it, we need to decide if it's ionic or covalent. And if we look up sulfur, we see it is a nonmetal. Oxygen is a nonmetal as well, so I know this is a covalent compound. That means I'll use the prefixes. So I name them in order. And then I need to say, so we don't say mono, but I do need to say di for the oxygen. And again, even these end in "ide." Okay, here's another one. Copper is a metal. And really, if it has a metal, it's going to be ionic. But anyway, metal, non-metal, so this is ionic. And I name them in order, no prefixes. But I know that copper can have more than one charge. It's in the middle of the periodic table, hard to predict. And so I need to figure out what that Roman number should be. Chlorine is in the -1 column, so this must be a copper with a +1 charge. Again, a metal, and this one's a polyatomic ion. So I need to figure out the charge, so it's ionic. Need to figure out the charge on the lead. So let's look up, this is polyatomic ion, this is nitrate. And its charge is -1. So then since there's 2 of these -1s, this lead must be +2 to make it neutral. So then I do the name, metal first, metal's always first, its charge, the last name, I name the polyatomic ion,